Assalamualaikum warahmatullahi wabarakatuh. Hey, good morning to all my students. Okay, so today we are going to continue our discussion with topic 5 for we call our discussion in topic semester 1. The topic of function and graph. As you see the screen here now, we are going to look at 5 different subtopics. With the first 5.1 functions, 5.2 composite function, 5.3 inverse function, 5.4 exponential and logarithmic functions, and 5.5 trigonometric function. Okay, so we're going to look at the first one here, 5.1 functions itself. Okay, so the objective of this topic, at the end, students should be able to define a function, give a definition of function, and identify a function from the graph using the vertical line test, and state the domain and range of a function. So class, we are going to, for this topic, we will look into a function when we have x-axis and y-axis. So domain is all about x, meaning the value that lies on the x-axis, and for range is all about y-axis. Okay, and then students should be able to sketch the graph of a function. Define the function is a linear, quadratic, cubic, whatsoever then, and how to sketch the graph. And then identify a one-to-one function using algebraic approach or horizontal line test. So, definition of function. So, a function is defined as a relation in which every element in the domain, or X, has a unique image. Okay, unique means one. Okay, unique means one. Unique image element in range. Okay, range is in Y. So, in other words, a function is one-to-one relation or many-to-one relation. So then, for example, this is one-to-one relation. One element, every element in X is mapped to an element, every single element in the group of Y. And also here is either one-to-one or many-to-one. Okay, more than one element in X. This is 2 and 3 here, more than one, mapped to one relation, or what we call one element in group of Y. So a function which element of range is mapped to at least one element of domain. Okay, a function which each element in the range, meaning each element in Y, is mapped to at least one element of the domain. So there is no element in Y that not being mapped by the element from X. In this case, A is not being mapped from any element from X. Okay, so in this case, there's an element of Y, which is A, is not being mapped from any element of X. Okay, so this is not it. A function which every element of range corresponds to exactly one element of domain. A function, one-to-one function, a function which every element the range corresponds to exactly one element of domain. Okay, so every single element from Y, element in Y is being mapped by the element of X by single. Okay, but not for this one here. A function, one-to-one, every element range to correspond to exactly one element. So there is an element of Y is not being mapped by X from X. So how do I identify a function in a one-to-one function? So class, to identify whether it's a function, we are using the vertical line test. So this is vertical line test. And it's either one-to-one function or not, we are using the horizontal line test. Or second option, we can use the algebraic approach. So, vertical line test. Draw a vertical line parallel to y-axis. Draw a vertical line parallel to y-axis. So now, for example, here, as you can see on the screen here now, the red line is cutting at one point, okay, cutting at one point of the graph where this red line is parallel to the y-axis or fx. Okay. So I'm trying again another vertical line. Okay, for example, it cuts at one point and also cuts at one point. So it's a it's a function. The graph is a function. Let's say for this one here, this red line cuts at 2 points of this curve of x. So just imagine that at one value of x, there are two values of y, which is y1 and y2. Then the graph is a function. Okay, this graph is a function, and this is not a function. Okay. So horizontal line test, draw a horizontal line to a parallel of x-axis. Parallel of x-axis means that same direction or parallel here with the x-axis. Okay, so you can see here now this line, this red line, cut the graph at one point. So there's one value of x and one value of y. Okay, then the graph is a one-to-one function. But then look at this one here now. When we have x1 and x2, there are one value of y. So this is many to one. It's not a one-to-one function. Okay, the graph itself must be identified as a function first. So algebraic approach. Okay, a function f is said to be one-to-one function if each different element in x corresponds to a different image in y. So substitute the value of x1 and x2 into a domain of f in the function. Then if x1 equal to x2, then it is one-to-one function. And we come up with a conclusion that if x1 equal to fx2, then x1 equal to x2, where x1 and x2 is an element of the domain of f. Okay. Okay, so given to us a function of x squared minus 3. So class, where we call the highest degree of x, which is 2, from this example, this is an quadratic, okay, quadratic equation. Okay, x squared minus 3. So let's imagine that if fx1 equal to fx2, so substitute x with here with x1 squared minus 3 equal to x2 squared minus 3. Okay, so from here, just imagine that if we add up with 3 left and right, okay, it's clear here now, is x1 squared equal to x2 squared. To make it x equal to an x something here, we are going to square root left and right. Okay, square root of x squared, it gives you x1, and the result on the other side, it come up with a positive and negative x2. Okay, so from here, one value of x, okay, one value of x1 here equal to positive and negative. There are two values of x2 here. Is either positive of x2 or negative x2. So then x1 equal to positive of x2 or x1 equal to negative x2. So this is not a one-to-one function. So for this function of fx is not a one-to-one function. Okay, now the function of fx equal to 1 over x cubed. Okay, class, why do we have this? Why? Yes, because the denominator cannot be equal to 0. Okay, so then the value of x is all valid from negative to positive infinity except when x equal to 3, because when 3 minus 3 equal to 0, 1 over 0 is undefined. So we can define what is the value of 1 over 0. Okay, now, so for this one here, let x1, x2 is the element of D. Okay, then fx1 equal to fx2. 1 over x1 minus 3 equal to 1 over x2 minus 3. Okay, so we're just comparing the denominator left and right. x1 minus 3 equal to x2 minus 3. So it's either plus with 3, adding with 3 left and right, or bring this to the other side. Okay, so then finally we get x1 equal to x2. So fx1 equal to fx2, then we come up with the conclusion that fx is one-to-one function. Okay, there you go. So now class, sketching a basic graph. As we know that linear is a straight line. Okay, from fx equal to mx plus c. As we know that m stands for the gradient. Okay, the gradient is either positive or negative. And c is the value of y when the function cuts at y-axis. Okay, when the function cuts at y, then we get the value of c. So y equal to mx plus c. And for quadratic, from the basic function of y equal to ax squared plus bx plus c. So to determine whether its graph will give us the smile graph or set graph is all based on the value of a. Is whether a, okay, for this one is when a is greater than 0, and here is when a is greater than 0. Okay, and reciprocal fx equal to 1 over x, and square root function. Okay, so fx equal to this is actually that if we have y equal to x squared, x equal to y squared, actually it gives us the graph of full complete curve, but then open up to the left or open to the right. So when we have fx equal to square root of x, then it's just half of it. Okay. So domain and range. Can you see the difference? All the graph be affected by the intercept, value of x and y. We show the importance of domain and range. So horizontal axis, x-axis, represent the domain, and vertical axis, y, represent the range. Okay, so from relation of x and y is either one-to-one or not one-to-many, many-to-one or many-to-many. So class, the domain is all the value of x that makes the function defined. Okay, for all values of x that we can substitute into the function of f, And the domain is all about the y. Okay, codomain is all the values in y, 0, 1, 4, 9, and 16. But then the range is the value of y, value in codomain or y that be mapped from the element from x. It's only 1, 4, 9 is being mapped from the x. 0 and 16 are not. So range is 1, 4, and 9. Domain and range can be determined by using the graph or algebraic approach. So find the domain and range of function by using graph. Okay, so now let's say we have the graph of y equal to 2. So y equal to 2 means it's a horizontal line of graph. So class, actually that at every single of these tiny coordinate, okay, dot here along the line, or what we call the dot along this green line actually represent the value of x and y, x and y, x and y, x and y. So the domain of this function, if you see the domain of this function here, is all if all being mapped to the y-axis, we can see that the domain is from negative to positive infinity. And what about the range? This line for coordinate of y is just being mapped to the value of y, which is equal to 2. So the domain of this function f is R. R is a real numbers from negative to positive infinity. And the range of f is, we refer to the value of y is mapped to the value of y, which is equal to 2. Okay, on this one here. Okay, linear function. Okay, is whether we write down as an fx equal to y minus 1 or y equal to x minus 1. Y or fx is just because the way we write it is different. Okay, different approach of writing, but then it tells us the same thing, which is fx we equal represent by the y. Okay, now at this coordinate, there are many coordinates, okay, on this line, on this green line. So if we refer to the x-axis, let's say this graph is continuing. Okay, so at every single coordinate, it represents the x. Okay, at every single dot here represent the coordinate of x and y. Okay, it makes the line of this line of x minus 1. So we can say that all values of x is being used. We use the value of x, substitute into the function of fx that makes the function defined. Okay, and if we refer the same coordinate to the y-axis, okay, refer to the y-axis, all values of y is being mapped from the graph. Okay, so what is the domain of this function? The domain, yes, is all real numbers, meaning all values of x being used, we substitute into the function and makes that line of y equal to x minus 1. And what is the range of f? Yes, all values of y being mapped from the x from the function of fx equal to x minus 1. So the domain is all plus. This one also can be represented as from negative infinity to positive infinity. Or here is also from negative infinity to positive infinity. Okay. quadratic function. Let's say x squared minus 3x minus 10. Okay, by completing the square, then you get this here. I do hope that all of you still remember how to, what we call, the process of completing the square. Never mind, we'll talk that in the videos. So now class, from here, where x minus 3 over 2, x minus 3 over 2 equal to 0, then x equal to 3 over 2. And the value of y here, the value of y is negative 49 divided by 4. So actually that when we come up with the process of completing the square, this gives us the symmetrical of this graph. Symmetrical, do you still remember what symmetrical is? It's just like, let's say, imagine that this book, okay, okay, I think that from here you can't see it. Symmetrical is the middle line of the graph here. Okay, so this is the graph and this is the middle line. Okay, middle line of the graph. So class, okay, so the middle line here, this is where the x equal to 3 over 2 is 1.5. Okay, and then the lowest point of y, is negative 49 over 4. Okay, so this is the lowest value of y. So it is at the minimum of the graph. So what is the domain of this function? The domain, if we okay, let's say this is unlimited, okay, is keep continuing here. So if we refer to the x-axis, because as I said just now, there are many coordinates of x and y along this line or along this graph. Okay, if we refer to every single coordinate of this to the x-axis, so we will find that all values of x is being used or substituted into the function of f. Okay, and then if we refer to this coordinate to the y-axis, okay, so you guys, girls, you will find that all values, okay, not all values of y is being mapped from the function of fx. Okay, it's just, okay, it being mapped from here until here, negative 49 over 4. So then, what is the domain of this function? Yes, all real numbers, negative to positive infinity. But then the range, okay, the range or value of y, the lowest is negative 49 over 4 to the, to positive infinity. Positive infinity for the value of y. Okay. Okay, cubic function. Cubic means that the highest degree of x with the power of 3 here. Okay. So this is one of the simple example of the graph of x cubed, or we call cubic function, x cubed minus 5x squared plus 6x that we factorize. So class, if we make this one equal to 0, fx or y equal to 0, then we did get this one here, x equal to 0, x equal to negative x minus 2 equal to 0 or x equal to 2, and x minus 3 equal to 0 or x equal to 3. So the intersection point at x-axis, x equal to 0, x equal to 2, and x equal to 3. Okay, let's say the graph continuing down here and also up here. Okay, So class, there are many coordinates that makes the line of the function. Okay. Okay, so every single coordinate of this xy, if we refer to the x-axis, okay, we refer to the x-axis, we find that all values of x is being used, or we call be substitute into the function of fx. Okay, and then if we refer to the graph again to the y-axis, okay, let's say also here we refer to the y-axis, we also find that this one, all the values of y is being mapped from the function of fx. So class, what is the domain of this function? The domain is all real numbers and the range also all real numbers. Okay, okay, just class, this is just we call the graph of fx just to fit in this picture, but actually that this graph continuing positive to negative to positive infinity. Okay, square root function, this one here now. So class, just imagine that if fx equal to y equal to square root of x, if I square left and right, it gives you x equal to y square. X equal to y square is actually a graph, I call a curve, fully like this. Okay, this is the graph of x equal to y square. But now we are talking about square root function, square root just half of it, and we're talking about the graph of fx equal to square root of x. So look at all these tiny, small coordinates along this red line of the function fx. If we refer to the x-axis, okay class, actually that the graph will be something like this actually. Okay, so if we refer to the graph, to refer to the x-axis, all the values of x, all the values of x on the right side is being used, substitute into the function, and there's a limit where x equal to 0, 0 to positive infinity. And if we refer to this graph to the y-axis, so we'll find that all positive value of y is being mapped from the graph from 0 to positive infinity above that. So then, what is the domain of this function? From 0 to positive infinity, and range is also from 0 to positive infinity. Close bracket means that it is including 0. Absolute values function. Okay, so absolute value function class. Just imagine that if I bring up this discussion here for this example for a while. Let's say we have y equal to an x. As we know that y equal to an x is a line. Okay, y equal to an x, line that cuts at the origin point of 0, 0, and it gives us an angle of 45 degree. Okay, so now there's a value of y, okay, negative x. Okay, from here there's also we call negative x and also negative y, positive x and positive y. Okay, because the graph here, okay, at this point the value of x is positive and y is positive, and at this coordinate or point here, x is positive, y is negative. Okay, so when it comes to y equal to absolute values of x, all the graph, all the function, or the graph that below the x-axis, below the x-axis is where all the y is negative. Okay, when it comes to absolute values, this graph, we just like call, we bring above here, okay, and become a new graph of we call function y equal to absolute values of x, meaning this graph is we eliminate or delete the graph here. So that is the story of absolute values function, meaning any graph that lies below, sketch below the x-axis will shift above, reflects through the x-axis. Just now this is the graph, okay, that reflects through the x-axis, and now it is here now. Okay, so you can see that there is no graph that lies below the x-axis or for y negative. No, it's all for y is positive. Okay, from negative. Okay, at this point there is x here and also y. At this coordinate there's a x and also y, x and y, x and y. Here is also x and y, x and y, x and y. Okay, so what you can see here, what can you see here now? The all values of x from negative to positive infinity being used, like we can substitute into the function. Okay, but then for y, the graph is only mapped to the positive value of y, because there's no graph below here, below the x-axis, there's no graph, so we cannot point to the graph to the y-axis. So the domain is all real numbers from negative to positive infinity, and the range start from 0 to the value of y from 0 to positive infinity. Okay. Now, rational function, x, the denominator cannot be equal to 0, meaning that x minus 1 cannot be equal to 0, and x cannot be equal to 1. Class, so this line represents the value of x equal to 1. And as you see the screen here now, the graph will not touch or intersect this line of x equal to 1. It won't intersect. It's just approaching, getting close, and close. Getting close only. Getting closer to the line of x equal to 1, but it won't touch, it won't intersect or cut the line of x equal to 1. Okay, so class, what is the domain of this function? We can straightly refer to this. The domain is all real numbers from negative to positive infinity, except when x equal to 1. Okay, all x are acceptable, or the domain, except for x equal to 1. And the range, if you refer to the y-axis, you can see that is a map to all values of y except when y equal to 0. Y is equal to 0 is along the x-axis. Okay, so the range is from all real numbers except 1, and the range is all real numbers except 0, because the graph will approaching to the x-axis, getting close and close, but it won't touch the x-axis. So 1 over k, a function of 1 over k, then k cannot be equal to 0, or the denominator cannot be equal to 0. and square root of k is greater than or equal to 0, and this one here also k greater than 0, because okay, the denominator cannot be equal to 0 even though square root of k is greater than or equal, but then we cannot put 0 as a denominator here. 1 over 0 is undefined, so k can be only greater than 0. Okay, so now sketch the function and find the domain and range for each of the function given. Okay, so for fx equal to negative 2x squared plus 4x minus 5. Okay, plus for quadratic function, for quadratic with the highest degree of x, which is 2, all values of x, okay, can be recalled. We can substitute all values of x into this function and makes the function defined. So in that case, the domain of this function equal to all real numbers, or we can also write this as a negative infinity to positive infinity. Either one is all real numbers or from negative to positive infinity. Okay, what about the range? As we know that the graph of the quadratic function, we look at the coefficient of x squared, which is a, and at this moment where a equal to negative 2 means that it will give us the set graph. Okay, the set graph meaning there is a maximum, the highest value of y, the maximum point here. Okay, so negative 2x squared plus 4x minus 5. Process of completing the square. I still hope that you still remember on how to solve this. Factorize the negative 2 outside because we need to make sure that the coefficient of x squared equal to 1. So then x squared minus 2x plus 5 over 2. Okay, so let's say we multiply negative 2 to every single term here. Negative 2 times x squared, negative 2x squared. Negative 2 multiplied with negative 2x, positive 4x. Negative 2 times 5 over 2. Clear these 2 and these 2, it gives us negative 5. Okay, so then negative 2 x squared minus x plus x squared minus 2x plus negative 2 over 2 squared minus negative 2 over 2 squared plus 5 over 2. Okay, so then negative 2. Okay, for this 3 part, it gives us x minus 1 squared. And then negative 2 divided by 2 equal to negative 1. Negative 1 squared equal to positive 1 and minus 1 here plus 5 over 2. And this is going to give you a negative 2 over 2 plus 5 over 2, which is 3 over 2. So negative 2 multiplied with this and also multiplied with 3 over 2. So it gives us this one here, negative 2 x minus 1 squared plus or minus 3, sorry, minus 3. Negative 2 multiplied with 5 over 2. Okay, again, negative 2 multiplied with 3 over 2 equal to negative 3. So class, this is the record the maximum coordinate of this. Okay, the maximum coordinate of this, which is x equal to 1 and y equal to negative 3. So class, sorry again. Okay, a coordinate of 1 where x equal to 1 here and negative 3 here. So the graph will be something like this. Okay, the graph will be something like this, a curve that below the x-axis, and the highest value is -3. So what is the domain of this function? The domain already mentioned here, which is from negative to positive infinity. And the range of f, okay, the highest value of y, which is -3 here, and to negative infinity. So then 3 to -3 to negative infinity. Okay. Okay. So now class, let's say if we like to find the domain and range using the algebraic approach. So we write down all the function of fx here. Okay, y equal to, okay, we have already showed that we come up with the completed square process until we get this one here, -2x minus 1 square minus 3. Okay, so then, so bring this -3 to the side, y plus 3 equal to -2x minus 1 square, and divide by -2, then you come out with y plus 3 divided by 2 negative equal to x minus 1 square, and we squared left and right. To eliminate this square here, then we get x minus 1 equal to square root of negative y plus 3 divided by 2. Okay. And then x equal to 1 plus square root of negative y minus y plus 3 divided by 2. Okay. So this is our reference now to make the function define. So then negative y minus 3 divided by 2 greater than or equal to 0, because if square root of 0 equal to 0, so 1 plus 0 is still has a value. Okay, so then for this one here now, cross multiply here, negative y minus 3 greater than equal to 0, negative y greater than equal to 3, and y is less than or equal to -3. So the range of this function, look at this one here now, is all from -3 to negative infinity. So then the range of f equal to -3 to negative infinity. Supposedly that negative infinity until -3, sorry. Okay, so that is that. Okay, so we find that we call the domain and range using the graphical approach, and we call using the graph approach and algebra approach. Okay. And now, okay. Y equal to modulus of x plus 2. So class, just imagine that if I come up, okay, I write this one for y equal to x plus 2. Okay, the graph of this x and y. Okay, when x equal to 0, y equal to 2. When x equal to 0, y equal to 2 here. And when y equal to 0, or x plus 2 equal to 0, then x equal to -2. So this is the graph. Oh, sorry. Okay, but now, as I said that when it comes to this absolute value sign, all the graph that below the x-axis, all the graph that below the x-axis will be shift above, okay, what we call that, shift above the x-axis, opposite of this one here, okay. If I suddenly remember what is the term for what I'm going to say, I'm gonna recall, then I'm back to you recall, gonna say that, reflex, sorry, reflex. This graph, okay, especially the one that below the x-axis, will reflex above through the x-axis. So then it becomes like this, okay. So there will be no more graph that below the x-axis, and this is the graph of absolute values of x plus 2. Okay, so now, what is the domain of this function? The domain, all values of x, am I right? All values of x? Yes, it's from negative infinity to positive infinity. And the range? Range will refer the graph to the y-axis. Okay, we refer to the y-axis. So it is from 0 to positive infinity. Okay. If we find the domain and range, we call it algebraic approach. Okay, algebraic approach, as we know that modulus of, okay, we refresh for what we had learned in topic 1 or topic 2, something like that. Modulus of fx or x plus a equal to, we divide into two definitions here, where x minus plus a for x greater than or equal to negative a, and negative x plus a for x less than negative a. Okay, so from here, for this one here now, fx equal to, we divide into two definitions, which is x plus 2 for x greater than or equal to negative 2, and negative x plus 2 for x that less than negative 2. So then the domain of this function, look at this and look at this, automatically these are the domain of the function. So the domain of f equal to, first is less than negative 2, less than negative 2, which is negative infinity until negative 2, union, okay, this one greater than or equal negative 2 to positive infinity. Okay, so because, okay, look at this point, at negative 2, one is just less than, another one is greater than or equal, including negative 2. For union here, we just assume that it also include negative 2, so it is from negative to positive infinity. And then the range for any absolute value of I, for any absolute value of y which is greater than 0, okay, therefore the range of f equal to 0 to positive infinity. There you go. Okay, find the domain and range for each of the function given here. I don't think that I'm going to show both of this for A and B. I let all of you to try by yourself with one of it, because for these two, we already explained, during example that we call the example of explanation of this a few minutes ago. Okay, so I'm just going to show you for A only. Okay, so fx equal to square root of x plus 2. As we know that square root of 9 equal to 3, square root of 4 which is equal to 2, square root of 0 equal to 0, square root of negative 4, Yeah, I do hope that students you still remember when it comes to square root of negative, what's going to happen then? Yes, we are dealing with imaginary part or complex number. But for this case, we are dealing with only real numbers, meaning for this one is undefined. Okay, this is undefined. So now, with this simple explanation, meaning we call the value inside this square root sign is must all positive or at least equal to 0. Equal to 0. So we're using this explanation here for this one that x plus 2 is greater than or equal to 0, then x greater than or equal to negative 2. So class, automatically this is the domain of this function. Okay, and then the graph of this, when x equal to negative 2, negative 2 plus 2 equal to 0, square root of 0. So f negative 2 equal to square root of negative 2 plus 2 equal to 0, square root of 0 equal to 0. Okay, x negative 2 and y equal to 0. This is negative 2, and y equal to 0. And the graph will be something like this. So, according to if we map this graph to the y-axis, so then the range, okay, for this one here, it is from negative 2 to positive infinity. And the range of f equal to 0 to positive infinity. Okay. So for question B, fx, this one here, you try by yourself. Okay. And for exercise 1, identify whether the function is 1-to-1 or not. Okay, for this one, yes, it is 1-to-1 function. You try by yourself. Exercise 2, find the domain and range for each of the function given below. Exercise 2, the domain of this, the domain here is for 2 to positive infinity, and the range is 3 to positive infinity. And for B, it is x greater than or equal to negative 1. And the range 0 to positive infinity. So find the domain and range for this one here now, where, okay, give it a final answer for you to try. The domain is all real numbers, negative to positive infinity, and the range of f equal to 2 to positive infinity. So class, that's all for today. For exercise, you try on your own, sketch the graph and see whether we go the domain and range for every of the function. And that's all for today. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh. Have a nice day.